All right, guys, so this section is coordinate proofs. It's the last section of chapter 8. It's 5.8. And all we're doing is we're writing proofs, but our visuals and pictures will be in the coordinate plane. So that should actually help things out, because if you think about it, you can get any side length on a coordinate plane just by doing the distance formula. So what I've done is up here, I've written the distance and the midpoint formulas. If you don't know these, please get to know them pretty quickly, because you will use them quite a bit in this. All right, so this one here, we want to prove that SO, which is right here, bisects angle PSR. Okay, well, the only way to prove that this bisects that angle would be to show that this angle and this angle are congruent. Well, the only way I can see to show that that angle and that angle are congruent would be to make these triangles. So here's one, and here's another, to show that these are congruent, and then we could use CPCTC to show these angles are equal, which would then show that SO bisects that big angle. Okay, so let's go ahead and start. Now from here to here, we don't really have to do any math with that. We know from 0, 0 to 3, 0, that's 3. And we know that -3 to 0, 0, that's also 3. So we know that PO is congruent to OR, and I'm going to put in parentheses 3, by that's given in the diagram. Okay, well now, if you look at this, they share this middle thing, and we can just count 1, 2, 3, 4. So I could say that SO is congruent to SO, which is 4, by the reflexive property. Okay, now I want to find the distance here and the distance here. So PS. Okay, so for PS, I'm going to use 0, 4 and -3, 0. So I could say -3 minus 0 squared plus 0 minus 4 squared, which is equal to -3 squared plus -4 squared. Remember, a negative number squared is a positive number. So this is 5. Okay, and then I'm going to do the same thing for SR. So I'm going to use 0, 4 and 3, 0. So SR, let me scroll down a little bit. So square root of 3 minus 0 squared plus 0 minus 4 squared, which equals 3 squared plus -4 squared. 3 squared is 9, -4 squared is positive 16, square root of 25, which is 5. So this is 5. So I can say that PS is congruent to SR. I'm going to put in parentheses 5. By the, I'm going to put distance formula from diagram. And guys, there's various ways you can say that. I'm not sure what Big Ideas wants you to say, but something of that nation. So now that I've said this side's congruent, this side's congruent, and this pair of sides congruent, so I can go ahead and say that triangle PSO is congruent to triangle RSO by the side congruence theorem. Okay, and then it's back to what we talked about. So that would mean that this angle and this angle are congruent. So angle PSO is congruent to angle RSO by CPCTC. Corresponding parts of congruent triangles are congruent. And then if those angles are congruent, that means that SO must bisect the bigger angle, which is angle PSR, just by the definition of bisect. And that's our proof. All right, guys, so let's look at example 2. Now, why don't you go ahead and try to do this one on your own, and then we'll go over it. All right, so hopefully you got through this one okay. It wasn't too hard. So you first start with the given, which is that we have a ray that bisects an angle, so that means these two angles right here and here are congruent. So immediately we have a pair of angles that are congruent. Okay, we know it shares GJ, so that's kind of a gimme. So that'd be one of the two sides. Now, if you guys found JO and JH to be congruent, and then used angle side side, that would be wrong, because remember, we don't have an angle side side theorem. Okay, we do have a side angle side theorem though. So in order to use the side angle side, the angle has to be between the two sides, which means we need GO and we need OH. Okay, so when you do the distance formula in GO and GH, you should have got the square root of 34 for both. So I just wrote that they're congruent, and I wrote square root of 34, distance formula and diagram, and then these triangles are congruent by the side angle side theorem. All right, let's look at example 3 now. So we have this this picture here, and it says we're suspending this, and it's like a triangle here. Okay, so it says you buy a tall 3-legged plant stand. When you place a plant on the stand appears to be unstable under the weight of the plant. The diagram at the right shows a coordinate plane superimposed on one pair of the plant stand's legs. The legs are extended to form triangle OBC. So here we have triangle OBC. Prove that triangle OBC is a scalene triangle. Okay? So this isn't going to be too hard. So to prove that it's scalene, well, first you have to know that scalene means that we have 3 sides that have 0 congruent. So all 3 sides are different lengths. Well, OC is from 18, 0 to 0, 0, which is just 18. Okay, so we have OC equals 18. Now to find OB, we're just going to use the distance formula. We have 12, 48, and 0, 0, so it'd be 12 minus 0 squared plus 48 minus 0 squared. Alright, so when I get my calculator out, I get this is square root of 144 plus 48 squared is 2304, which is roughly 2448. And we're not going to worry about simplifying that. Okay, so that's OB. Alright, now to find BC, we do the same thing, but this time we'd be using 12, 48, and 18, 0. So it'd be 18 minus 12 squared plus 0 minus 48 squared, which gives me 6 squared plus negative 48 squared, which is 36 plus 2304, square root that, which is then equal to square root of 2340. So as you can see, this is a different number than this, which is a different number than this, and therefore we do have a scalene triangle. And because this is a scalene triangle, guys, it would make sense that this is kind of wobbling, because these two legs right here are different lengths. Alright, let's do this last example here. We want to show that this triangle here is congruent to this triangle here. Alright, well, the first thing we notice, the easy thing, is that they share this side. So I can just say ON is congruent to itself by the reflexive property. Okay, now let's look at OP. Okay, now if we look, our X value doesn't move. We're not going left to right, we're just going straight up. So if we start at 0 and go to 2H, OP is just 2H. Okay, same thing, OM, same but different. Now, we're not moving up or down, we're just moving left and right, but we're going from 0 to 2H, so the length is still 2H. So I can say that OP is congruent to OM, I'm going to put in parentheses, 2H, by the diagram. Alright, so now I need to show, first of all, let me mark this, that's congruent to that. Now I need to show that this piece here is congruent to this piece here. So we're going to pull out the old distance formula. So PN. Okay, so I'm going to use these two here. So square root of, so 0 minus h squared plus 2h minus h squared, which is negative h squared plus positive h squared, which is h squared plus h squared, which is the square root of 2h squared. And if we actually, let's not even simplify that. We can just leave it here. All right, now let's look at NM. Okay, so now we're going to use h, and 2h0. So 2h minus h squared plus 0 minus h squared. Well, 2h minus h is just h plus negative h squared, which is the square root of h squared plus h squared, which is the square root of 2h squared. So notice these are the same, so I can say Pn is congruent to Nm square root of 2h squared. Guys, I know you can simplify that, but we haven't worked on it. And that's distance formula using diagram. Okay, so I've shown that this now is congruent to this. So I can now state that triangle NPO is congruent to triangle NMO by the side, side, side congruence theorem.